Hello guys, welcome to another video here on the pre-security part, and we're currently treating the how the web works module, and we're currently on the last room. Today we'll be treating the putting it all together room, and without further ado, let's jump into it. Okay, so right here on the putting it all together room, we're going to learn how all the individual components of the web work together to bring you access to your favorite websites. Now we skip the walkthrough video and let's go straight to task 1, putting it all together. Now from the previous modules, you would have learned that quite a lot of things go on behind the scenes when you request a web page in your browser. Now, to summarize, when you request a website, your computer needs to know the server's IP address it needs to talk to. For this, it uses DNS, all right, the domain name system. Now, your computer then talks to the web server using a special set of commands called the HTTP protocol. Now, the web server then returns HTML, JavaScript, CSS, images, etc., which your browser then uses to correctly format and display the website to you. Now, as you can see, there are also a few other components that helps the web run more efficiently and provide extra features. We're going to see that, I guess, in this task too. Now, you see that you request website in your browser. It goes through to find the web server IP address with DNS, and then you view the website because it's connected to the web server. I think it's more or less, the DNS connected to the web server, then you view the website. Now, okay, answer the question. I've read this. All right, now straight to task 2. Now, other components. Now, let's read about load balancers. Okay, when a website's traffic starts getting quite large or is running an application that needs to have high availability, now one web server might no longer do the job. Now, load balancers provide two main features: ensuring high traffic websites can handle the load and providing a failover if a server becomes unresponsive. Okay, now when you request a website with a load balancer, the load balancer will receive your request first, then forward it to one of the multiple servers behind it. Now, the load balancers use different algorithms to help it decide which server is best to deal with the request. Now, a couple of examples of these algorithms are round robin, which sends it to each server in turn, or weighted, which checks how many requests a server is currently dealing with and sends it to the least busy server. Makes sense? Now, the load balancers also perform periodic checks with each server to ensure they are running correctly. This is called a health check. Makes sense? Now, if a server doesn't respond appropriately or doesn't respond, the load balancer will stop sending traffic until it responds appropriately again. Okay, so this is more like different servers, I guess. Now, what is a CDN? A content delivery networks. A CDN can be an excellent resource for cutting down traffic to a busy site. CDN, makes sense? Okay. Now, it allows you to host static files from your website, such as JavaScript, CSS, images, videos, and host them across thousands of servers all over the world. CDN, content delivery networks. Okay. Now, when a user requests one of the hosted files, now the CDN works out where the nearest server is physically located and sends the request there instead of potentially to the other side of the world. Now, databases. Now, often websites will need a way of storing information for their users. So web servers can communicate with databases to store and recall data from them. So web servers work with databases, I guess. Now, databases can range from just a simple plain text file up to complex clusters of multiple servers, providing speed and resilience. Now, you will come across some common databases like MySQL, MS SQL, MongoDB, GraphQL, and Postgres, and more. So each has its specific features. Now, let's talk about the WAF, Web Application Firewall. And now, a WAF sits between your web request and the web server. Now, its primary purpose is to protect the web server from hacking or denial of service attacks. Now, it analyzes the web request for common attack techniques, whether the request is from a real browser rather than a bot. Now, it also checks if an excessive amount of web requests are being sent by utilizing something called rate limiting, which will only allow a certain amount of requests from an IP per second. Now, if a request is deemed a potential attack, it will be dropped and never sent to the web server. Makes sense. Now, what can be used to host static files and speed up clients' visits to a website? That is the CDN, the content delivery networks. Okay. Now, what does a load balancer perform to make sure a host is still alive? What's the English there? It performs, what's it called? Weight lift? No, what's it called? Health check. It performs what we call health check. Is that it? Health check. Let's check. Health check. Let's check. Health check. Please. Yes, great. Performs what we call health check to check if the host is still alive. Now, what can be used to help against the hacking of a website? The WAF, the firewall, the web application firewall. Great. We are done with task 2. Now, straight up here is task 3. How web servers work. Now, what is a web server? Now, a web server is a software that listens for incoming connections and then utilizes the HTTP protocol to deliver web contents to its clients. And the most common web server software you will come across is Apache, Nginx, IIS, I guess, and Node.js. Now, a web server delivers files from what's called its root directory, which is defined in the software settings. For example, Nginx and Apache share the same default location of /var /www /html in Linux operating systems, and IIS uses the C inet pop, I guess, and then /www root for the Windows operating systems. Okay, so for example, if you requested the file http www.example.com /picture.jpg, it would send the file via www.html.picture.jpg from its local hard drive. Okay, makes sense now. Now, virtual hosts. Now, web servers can host multiple websites. Yes, I've heard of this, with different domain names. To achieve this, they use virtual hosts. Now, the web server software checks the host name being requested from the HTTP headers and matches that against its virtual host. Now, the virtual hosts are just text-based configuration files. Now, if it finds a match, the correct website will be provided. If no match is found, the default website will be provided instead. Okay, virtual hosts can have their root directory mapped to different locations on the hard drive. For example, 1.com being mapped to via www website_1 and 2.com being mapped to via www.website_2. There's no limit to the number of different websites you can host on a web server. Alright, makes sense. Now, what's the difference between static versus dynamic content? Let's see that. Now, static content, as the name suggests, is content that never changes. Static. Now, common example of these are pictures, JavaScript, CSS, etc., but can also include HTML that never changes. Furthermore, there are files that are directly served from the web server with no changes made to them. Now, dynamic content, on the other hand, is content that could change with different requests. Now, take for example a blog. On the homepage of the blog, it will show you the latest entries. If a new entry is created, the homepage is then updated with the latest entry. Or a second example might be a search page on a blog, depending on what word you search. So different results will be displayed. Okay, so it has to be dynamic content. Yes. Now, these changes to what you end up seeing are done in what is called the backend. These changes to what you end up seeing are done in what is called the backend. Okay, backend. Now with this backend, with the use of programming and scripting languages, it's called the backend because what is being done is all done behind the scene. You don't see it. Now you can't view the website's HTML source and see what's happening in the backend, while the HTML is the result website HTML source. And okay, I get it. Now while the HTML is the result of the processing from the backend, everything you see in your browser is called the front end. Makes sense. Client side and server side, I guess that's the basic difference. Now scripting and back-end languages, there's not much of a limit to what a back-end language can achieve, and these are what makes a website interactive to the users. Now some examples of these languages in no particular order: PHP, Python, Ruby, Node.js, Perl, and many more. These languages can interact with databases, call external services, process data from the user, and so much more. A very basic PHP example of this would be if you request the website www.example.com index blah 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 blah. Now if index.php was built like this: HTML body hello, PHP echo get name this, it would output the following to the client: HTML body hello. So you see this part, the PHP echo gets the name, and all this would no longer appear. It will only just give you the hello Adam part. Okay. Now you will notice that the client doesn't see any PHP code because it's on the back end. Now this interactivity opens up a lot more security issues for web applications that haven't been created so securely, as you learn in further modules. Alright, now what does web server software use to host multiple sites? What does web server software use to host multiple sites? It's called virtual host. Sorry, I skipped my head for a minute. Virtual hosts. Okay, now what is the name of the type of content that can change? Dynamic content. What does client see? What does the client see the back end code? Yeah or nay? Nah, they can't see it. Right, that's the end of task 3, and let's go to the final task here, task 4, which is the quiz. Now click the view site button on the right. Let's click that, and yes, thank God this time it didn't give me a headache. Now using everything you've learned from the other modules, drag and drop the titles into the correct order of how a request to your website works. To review the flag, note: when placing a tile in the correct position, it will highlight in green. When a tile is in the wrong spot, it will highlight in red. Make sure not to refresh the page, as it will reset the tiles all to blank again. Let's do this. Okay, looks a lot. Let's see, total of 11. Okay, let's start now. What's the first thing? Request. Yes, request tryhackme.com in your browser. That should be the first thing. When you request, usually the web will check your local cache for IP address. I got that. And it will now check your recursive DNS server for address. Yes, correct. Now it will query this. Let's see. It will query the root server to find authoritative. Correct. And then it will, so you see, you request the tryhackme.com in your browser. Once you do that, it will usually check your local cache if you've used this IP or checked this website before for the IP address. If it doesn't get it, it will now check your recursive DNS server for address. After that, it will now query your root server to find the authoritative DNS server. The next thing will be it should be authoritative DNS server advises the IP address for the website. Correct. All right, now we're left with 6. Quickly, what's next? Next, once we've done that, we want to access the web server, I believe. So request. We have to check your payload, I guess. Web application talks to database. Yes, request passes through payload balance. No. Web application talks to database. No. I guess it's request passes through a web application firewall, and then it now passes through a load balancer, I guess, and web application talks to database. No, it now connects to web server on port 80 or 443 HTTP. After that, it's now web gets, the web server requests the get request. Web application talks to database to get that request, and this, your browser renders the HTML into your website, into a viewable website. Now, great, you did it. This is our flag, and amazing. Great. That being done, let's paste this, and that is the end of this room. The next room we're getting into is the Linux or Linux Fundamentals Part 1. Thank you for learning with me in this particular module on how the web works, and it was an awesome one. So I'll see you guys in the next room. Have a nice day. Ciao.